want to look at the parts that make up a parabola, and not necessarily as a function, but as a conic section. So what I'll do is I will reference this parabola over here to the right that opens upward. I'll use it to kind of illustrate the parts, but I'll also show you where the parts are on the other three types of parabolas. The one that opens downward, something like this. I know that looks terrible. Sorry about that. One that opens to the right, and one that opens to the left. Okay, so we'll talk about all the parts of all four, but I'll make this one larger so it's easier to tell. The first part we're going to look at is called the vertex. And in general, the vertex of any two-dimensional shape is like a peak, a point. So the vertex of a parabola is the peak of the curve. And so in this particular parabola, it's the lowest point. That's our vertex. Over here, it's going to be the rightmost point. This one, it's the leftmost point. And this one, it's the highest point. Okay, so that's the vertex, the peak of the curve. All right, then we have the focus. The focus is a point as well. It's not actually on the curve. It's actually within the curve. All right, so and it's in line with the vertex. So the focus of this parabola is somewhere up here within the curve, in line with the vertex. So the focus here on the parabola that opens left, the focus is to the left of the vertex. The parabola that opens right has the the focus to the right of the vertex. And when it opens down, the focus is below the vertex, okay, within the curve. And that's true for every conic section. A focus is always within the curve, and a vertex is always a peak of the curve. All right, the next thing that's unique to a parabola, however, is a p-value. Different books use different letters for this, but p is a common letter, probably for parabola. So the p-value is a distance, and it's a distance from the vertex to the focus. Okay, so in this parabola, this is p. Vertex to focus, over here, this is p, and this is p. All right? P kind of establishes the size of our parabola, and we'll see that in other videos when we do examples. But the next thing we have is something called the directrix. It's a weird word, directrix. The directrix is a line opposite the focus. Okay? And in fact, if the focus is p units away from the vertex, the directrix is also p units away in the opposite direction. So I'll measure p down, and I'll get my line, and in this case it's a horizontal line. If it were a vertical line, it would cut my parabola in half, and the directrix never does that. The directrix is outside of the curve. Never intersects it. So this is the directrix. Over here, let's measure our p-value opposite the focus. So that'd be here, here, here. So the directrix for this guy is a vertical line. It's a vertical line for this one as well, and it's a horizontal line for this one. Okay? So the directrix is exactly opposite your focus. The next thing is called the latus rectum. The one thing we have not done with our parabola is talk about how wide it is. We know that can vary. And so the latus rectum helps us to start nailing that down. The latus rectum is a line segment across the parabola, and it's through the focus. So if we're going to measure the width of this thing, we can measure it anywhere along this vertical axis. But since we have a designated point within the curve, namely the focus, why don't we measure the width right here? And so that is the latus rectum. And Over here, that would be a vertical line segment, a vertical line segment, and a horizontal line segment. The way we describe the latus rectum is where it ends, what the ends of it are. So when we get to examples, we'll actually nail down what point this is and what point this is. Those are called the end points of the latus rectum. Okay, that's how you describe the latus rectum. Okay, last but not least, we have what's called the focal diameter. It's focal because it's measured through the focus, and diameter because it's like a width. So it's like the width of the parabola. And it's measured through the focus. So just like the latus rectum. The difference is the latus rectum is a line segment and the focal diameter is a width. It's a number, okay? So the focal diameter here is the length of the latus rectum, and that's always true. The focal diameter is the length of the latus rectum. So over here, the focal diameter is this guy. Here it's this, and here it's this. So that's your focal diameter. Now this is the important part. This is the how they relate part, okay? How they relate. The focal diameter is always 4 times the p-value. All right, so it's always 4p. So if this distance is p, that means you have to go 2 p's to the right and 2 p's to the left, and that gives you 4 p's across, okay? So if p were 1 unit, you'd have to go 2 units to the right and 2 units to the left to get a total width or total focal diameter of 4 units, okay? So those are all the parts of a parabola. You can see how they vary for the different ways the parabola opens. And the important part is that the focal diameter is 4 times your p-value. And so we'll get to examples perhaps where the focal diameter is given, and then you need to determine the p-value. Well, if you want to go backwards, you would divide by 4 to get p, okay? So again, those are the parts of the parabola. Hope I made it clear. And let's get to some example videos.